Alright, let's look at the homework 8.1, problem number 8. Alright, so we want to sketch the curve with the equation x to the 2/3 power plus y to the 2/3 power equals 1. Alright, so let's do that. Alright, I'm going to actually borrow GeoGebra to sketch this picture. Alright, so let's type in x to the 2/3 power plus y to the 2/3 power is equal to 1. Right? So you can see that we get this picture here, and what we're going to do, it looks like, let's see, I don't know why it's missing there. Let's see, I'm going to just move this picture and see if we can see it better. Alright, yeah, alright, so we have that, and I'm going to just take this picture and put it there. Alright, so I'm gonna just close that and put it in there. Alright, so this is the picture we get. Alright, so it looks like we have 4 symmetric pieces here. So I'm gonna just try to find the length, arc length of just one piece. So from here to there. Alright, so let's find I'm going to call it L1, right? Alright, so let's find the equation. Start with this original equation. I'm going to subtract x to the 2/3 power, right? So we have y to the 2/3 power is equal to 1 minus x to the 2/3 power, right? Then we can raise it to the 3/2 power so that we can isolate y. Alright, but since there's a square root involved, so we have to talk about the plus or minus. Right? 1 minus x to the 2/3 power, raise it to the 3/2 power. Alright? So the plus version is basically the top one, and the minus version is the bottom one. So I'm going to use the top one, right, for that piece. Alright, let's take the derivative. Dy over dx is going to be equal to, put the 3/2 in front, then keep the same inside function. So 1 minus x to the 2/3 power. Right? Subtract 1 from the power, so you have a 1/2 power. And multiply by derivative of inside, so it's going to be negative at 2/3 x to the negative 1/3. Right? Then we can simplify. Let's see, we have 3 on top and 3 on the bottom, and 2 on top and 2 on the bottom, and the 2 on top. Alright, so we have, let's see, looks like there's a negative sign there. Right, maybe I should circle that so that I don't forget. Right, then you have on top, right, since this is a 1/2 power, so it's a square root of 1 minus x to the 2/3 power. Right, so I took care of this guy right here. Right, then we have x to the, so since it's a negative power, I can put x on the bottom, and it's a 1/3 power. Alright, then integrand is going to be square root of 1 plus, square this guy, so negative sign's gone, so you just have a 1 minus x to the 2/3 power over x to the 2/3 power. Right? So square root is gone, 2/3, sorry. A square root is gone, and I have to square the bottom, so it's a 2/3 power. Right? So if you simplify that by taking the common denominator, right, which is obviously x to the 2/3 power, right? So 1 is x to the 2/3 over x to the 2/3. Plus 1 minus x to the 2/3. Right? So we can cancel x to the 2/3 here and there. Right, taking the square root, you can get, let's see, this is going to be just 1 over x to the 1/3 because of the square root. So I'm going to write it as x to the negative 1/3. Alright, so that's the integrand. So we can find L1. So L1 is going to be equal to integral. Looks like it's going to start from 0 and ends up 1. Then we have x to the negative 1/3 power with respect to x. Right? So antiderivative would be add 1 to the power, so that's going to be 2/3. Divide by 2/3 is equivalent to multiply by 3/2. And then you're going from 0 to 1. Right? Plug in 1, you get the 3/2, minus plug in 0, it's 0 anyway. So you get the 3/2. Right? So if you want entire curve, we just have to multiply by 4. So L is going to be 4 times L1. So 4 times 3/2. So that will be 6, right? So 2 times 3. So it would be 6. Right? So let's check the answer. All right? So I'm going to go here. And we got 6. Alright, let's submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.